So in this problem, we need to resolve the given rational fraction into partial fractions. Now clearly, we observe that in this particular rational fraction, we have 2x minus 3. This is the numerator part. And then in the denominator, we have 3 factors. One of the factors is x minus 1. And then we have x squared plus 1. Now this factor is repeating twice. So in total, we have 3 factors. And that means that we can resolve this into 3 partial fractions. So let us suppose those 3 partial fractions be a over x minus 1. This is going to be the first partial fraction. Followed by, we have the next one, which is bx plus c divided by x squared plus 1. Now, the reason why we're considering bx plus c is because we have x squared plus 1, which is a quadratic factor. Then we'll have one more partial fraction, so that's going to be dx plus e. So this is going to be divided by x squared plus 1 whole square. Here x squared plus 1 is repeating twice. So let's label this as number 1. Our goal will be to obtain the value of these 5 constants a, b, c, d, and e. Okay, so let's try to solve this. So we'll begin with equation number 1, and we're going to multiply both sides with x minus 1 times x squared plus 1 whole square. Now in doing so, we'll see that on the left hand side, we're now left with only 2x minus 3, which will be equals to, now on the left hand side, we have x squared plus 1 whole square multiplied to a. Added to, and we have x minus 1 times x squared plus 1 multiplied to bx plus c. And then we have x minus 1 multiplied to dx plus e. So what we'll do, we're going to equate the coefficients of like powers of x, and that's going to give us a plus b. This will be equals to 0. This is going to give us one equation. Then we have b minus c, that will be equals to 0. This is going to be next equation. Then we have 2a plus b minus c plus d. So this will be equals to 0 as well. And then we have c minus d minus b plus e. This will be equals to 2. And then we have one more equation. So that's going to be a minus c minus e equals to negative 3. Now clearly we have 5 unknowns and we have 5 equations. So let's label this as Roman 1, 2, 3, 4, and 5. Now using any standard method, we can solve 1, 2, 3, 4, 5 to obtain the values of a, b, c, d, and e. So let me state those values, leaving this under exercise for you to try out. So a value comes out to be negative 1 over 4. The value of b, that's going to be equals to 1 over 4. C value, that's going to be equals to 1 over 4. The value of d, that's going to be half. And the value of e is going to be positive 5 over 2. Now what we'll do, we'll substitute all this value back in equation number 1. Therefore, we get 2x minus 3 divided by, we have x minus 1 in the denominator multiplied to x squared plus 1 whole square. So this will be equals to, so we have a over x minus 1. So we have negative 1 divided by 4 multiplied to x minus 1. Then we have bx plus c. The b value is 1/4 and c value is 1/4. So this will be x plus 1 divided by 4 times x squared plus 1. Then we have d value is half and e value is 5 over 2. So this will be x plus 5 divided by 2 times x squared plus 1 whole square. So we have successfully resolved the given rational fraction into 3 partial fractions.